So what is a gland? She said it's a cell, so it can be a cell or it can be a tissue, but what makes it a gland? Huh? But what's the significance of it? So if you call something a gland, you know it's going to do what? Secrete substance. That's it. What y'all think I'm looking for? So it's just a cell or tissue that secretes, that's the magic word, secretes some substance. Okay? So if it's called a gland, you know it's going to secrete some substance. Remember, there's a difference between endocrine glands and exocrine glands. So they both secrete substances, but what's the difference? Okay, think about the prefix, endo versus exo. Endo means inside, within. Exo means outside. So an endocrine gland is a gland that secretes substances within. Okay. Exocrine glands secrete substances to the outside surface of the body, for the most part, like sweat. Sweat glands are exocrine glands because the sweat goes through little tubes called ducts, and then it exits onto the surface of the body or into a hollow organ within the body. So exocrine glands secrete to the surface of the body, sweat glands, tear glands. But we also have exocrine glands that secrete digestive enzymes, for example. So they can an exocrine gland can also secrete into a hollow organ, such as the stomach or intestines. Okay, so exocrine glands, for the most part, they secrete to the surface, and then there are other exocrine glands that don't secrete to the surface of the body, but into some hollow organ. Endocrine glands, which is what this entire chapter is over, they secrete substance, but all of their substances are called hormones. Okay, so whatever endocrine glands secrete will be called hormones. That's one thing about endocrine glands. The other thing is that when endocrine glands secrete their substance, the substance doesn't go through a duct, D-U-C-T. So remember, exocrine glands have ducts. So sweat has to go through a duct before it makes it to the surface of the skin, for example. Endocrine glands do not have ducts. Instead, whatever they secrete is absorbed directly into the bloodstream. Okay? So the endocrine system is an organ of glands, a system of glands, and these glands are called endocrine glands, and they secrete chemicals directly into the bloodstream. Okay? And I want you all to start thinking more in terms of, instead of thinking of hormones as just chemicals, think of them as chemical messengers. So just like the nervous system is wired to control different aspects of the body, well, if the endocrine system can dump something into the bloodstream, what part of the body can it not have an effect on? If you have a system that can secrete messengers into the bloodstream, where do those messages end up? Everywhere in the body, right? So every cell in our body is in close proximity to a blood vessel. So think of those, the way these messengers work. The process is different in the nervous system, right? The nervous system has no connection with the circulatory system, right? So the signals just transmit through neurons from the nervous system and out to an effector somewhere. But the endocrine system is powerful in another way, because the glands, whenever they secrete a chemical messenger, it goes into the bloodstream and it goes all over the body. Okay? And for each of them, what you all need to think about is they're not just secreted at random. Everything has a purpose. So if a particular gland is going to secrete a chemical, it's because that chemical is needed for some activity. Let's go first to one that you all are familiar with. The pancreas. What do you know about the pancreas? So the pancreas is an endocrine gland. It's actually an organ that has both endocrine and exocrine function. So it secretes digestive enzymes, but the endocrine function, that is what we'll talk about here. So the pancreas secretes two hormones that you need to be aware of, insulin and glucagon. Let's look at insulin first. So you all probably have a pretty good idea what the purpose of insulin, right? What is the purpose of insulin? Good. So to regulate the amount of glucose we have in our blood. We talked about this last week. Why is that important? Why do we have to regulate how much glucose we have in our blood? What happens if we have too much glucose in our blood? Right. So properties of blood change, okay? And it's going to have effect on organs over time, the body's organs. So the body has to have a way of making sure there's just the right amount of everything in the blood. Electrolytes, sodium, potassium. But glucose especially, because too much glucose, you know what happens when people have diabetes and have to have their parts of their limbs cut off. But so the pancreas then has to know exactly when to secrete insulin and when not to. What's the problem if there is not enough glucose in the blood? Is that serious? Which is worse, having glucose too high or too low? Which is worse? How many say too low? How many say too high? So y'all don't know. Y'all just no idea at all, huh? So we know high levels of glucose can cause diabetes, and that can be serious over time. But if your blood glucose levels drop immediately, you won't have a chance. So you don't want your blood glucose to go too low, even for a minute, right? So there's a low point to where there's not enough glucose making it to what? Right? So that's why we keep going all the way back to why is glucose in the blood in the first place? Why do we have glucose in the blood in the first place? ATP, right? ATP where? Everywhere. So glucose has to be transported to all the cells in the body so the cells can make ATP. Without ATP, the cells die. So we don't want blood glucose levels to drop dramatically because it can cause death quickly. And you may hear this when people are on insulin, if they take too much. Have you heard of that? What happens if they take too much insulin, their blood sugar drops too low, and they can pass out, and that can be it can be fatal. All right. So, thinking in terms of, let's just say you're the engineer that created the human body, and you know that you have to have a certain amount of glucose in the body, in the blood at all times. What kind of mechanism could you put in that would make sure blood glucose didn't drop too low, right, when the cells were using a lot of glucose, and it didn't go too high when the glucose was not being used. So what you would put in is an organ that can somehow detect what? When blood sugar is higher, too low, and an organ that could produce some chemical. Think about that, y'all. The pancreas is made of cells, and there are just special cells that make insulin. So we don't have cells in our brain, in our lungs, that can make insulin. Only these special cells in the pancreas have the blueprint for how to make insulin. And then those cells have to know when to what? Secrete it. So on some signal that the blood glucose is too what? High, the pancreas knows to secrete insulin. And insulin has what effect? It lowers blood glucose levels by storing excess carbs. Okay? So back up. Think about that again. So the pancreas has the job of regulating blood glucose levels. What does it do? How does it regulate blood glucose levels? Whenever blood glucose what? Is too high, the pancreas is going to secrete insulin. And insulin is going to what? Insulin is going to cause the blood glucose levels to what? To go down. Right. So the pancreas secretes insulin. Insulin lowers blood glucose levels. Okay. Now there's this other column I want to mention just for a second. So you have the endocrine gland, the hormone that it secretes, and the effect that hormone has on the body. The target organ is the actual organ that responds to the hormone. Okay? So if we go back down, and keep that in mind, target organ. So what does that mean? That's the target organ responds to the hormone. So for insulin, most of the tissues are going to respond to insulin. And let me just help you make sense of this. The way insulin works, so if you can imagine, how is one chemical going to reduce another chemical in the blood? Insulin is sent into the bloodstream. Okay, and now it's going to do something to decrease the amount of glucose. Is it going to eat the glucose? Y'all understand the question? Okay, my question is, so you all just learned that insulin has what effect? Lowers blood glucose. But how? Okay. But how is that? Storing it where? So you're saying insulin has a little pouch to store? No, think about it. So you have one chemical and it's going to reduce the amount of some other chemical by storing it. But, Good. So it stores it in the liver, but that's not. So what this is saying then is insulin is going to flow throughout the body, right? Anything that makes it in the bloodstream is going all over the body. But the organs, the cells of the body, once insulin binds to them, they just open up and let glucose in. So that's all. That's what insulin is doing. Insulin goes to the cells, the body cells, tells them to open up and let glucose in. Because as long as the cells are closed, just like sodium gates, sodium can't get in until sodium gates open. So what tells sodium gates to open? Some type of stimulation. So it's insulin here that tells the body cells, okay, here comes glucose, open up and let glucose come in. So now that glucose is in the body cells, it's no longer where? in the bloodstream. So the problem is not too much glucose, it's too much glucose in the bloodstream. Okay, so if the cells don't need any, then quite a bit of it is stored in the liver. In the liver, remember how the liver stores glucose? In what form? In the form of glycogen. Very good. So remember, glycogen is a polysaccharide. Good. Polysaccharide, just like starch. So that's how insulin works. The pancreas releases insulin when? Before you all leave here today, you need to be able to tell me all about this. When blood glucose levels are too high. Thank you. Okay? Insulin is released where? Into the bloodstream. And then what? It circulates to all the cells of the body pretty much and tells them to open up and let glucose in. Glucose goes into the cells, so there's not that much left in the blood. Okay, so that's all we care about, too much in the blood. What about glucagon? So that's just half of the story. So this is glucose regulation. So the pancreas also regulates glucose by secreting glucagon, which is a hormone that has the opposite effect of insulin. So again, when you look at the pancreas has different types of cells. One set of cells will produce insulin and glucagon, and then the digestive enzymes. So those cells just know when to secrete, when to produce, when to make the glucagon, and then when to secrete it. Now, but here it says glucagon, the target organ of glucagon is the liver. Explain what that means. So remember, the extra glucose is stored where? In the liver. All the other body cells need their glucose. So they're not about to release glucose when blood glucose is too low. So this is what happens when blood glucose levels fall. How does the body increase the amount of glucose circulating in the blood? Well, glucagon is released, and glucagon, where does glucagon go immediately? So it's in the pancreas. The pancreas releases it. Where is it next? In the bloodstream. Okay? So anything in the bloodstream can go anywhere in the body. But only the liver is called the target organ here. So what does that tell you about target organs? Awesome. Very good. So all that means is the liver is the only organ that has a receptor for glucagon. Y'all get that? So the liver, glucagon is circulating around the body just like insulin is. Insulin has an effect on all the body cells because those body cells have what? Receptors for insulin. Okay? So they're going to react to insulin. They don't have a receptor for glucagon, so the body cells are not. The glucagon will pass by the body cells, but they won't react to it because they don't have a receptor for it. Okay? Y'all get that? Isn't this amazing how the body is put together? An explosion put all these instructions in step by step. All right. So glucagon binds to the liver, and the liver then knows to start what? Doing what to glycogen? Breaking it back down to glucose and releasing it into the blood. And that causes the blood glucose levels to increase. Okay? It says increases blood glucose levels by breaking down the stored carbs, which would be the glycogen. So that's how the endocrine system works. Now, it's easy when you learn it that way. I don't think you all will forget it too easily unless you just don't look at it for a month. But if you get it in your mind like this, you'll never forget it. And it's going to be hard to do that with all of the other ones because there's so many of them. But you should have an idea that whatever the gland is, it has a set number of hormones that can be secreted at a particular time, and it's going to cause some activity to change in some part of the body. So quite a bit of this test is going to be memorization, and you have 2 weeks, but for this you need to kind of start now. And what a lot of students do is use note cards. Any of you all use note cards to study? If you don't use it for any other part of anatomy and physiology, this will be a good part. Yes?
So our next test is going to be on
17 and 18. Yes. Okay? But most of the endocrine system information is right here on this table. There are some other study hints, but most of the questions that I will ask will have to do with the information right here in these tables. So you also, excuse me, so it gives you some information at the top of how to prepare and what other things you need to know. So let's just look at what the glands are. So what I would do is I'd have a stack of index cards, and on one card I'd have anterior pituitary, another card I'd have posterior pituitary on down. So have all of your glands, and on the opposite side of that card for anterior pituitary I would have a list of the hormones. And so this is the memorization part that I hate. I really don't like memorizing, but what you'll find is some of the names of the hormones will help you remember what they do. Okay? So even when I'm memorizing, I'm trying to find ways to make it make sense so it's less memorization. For example, and notice I say you only need to know the ones in red. So on the test I'm not going to ask you the function of or the effect of FSH, but you do need to know that it is a hormone that comes from the what? Anterior pituitary. Right. Yes. So the gland, you need to know all the hormones from that gland. If I ask you the hormone, you need to know what gland it came from. And you also need to know the effects, but the effects that you need to know are in red. So the one here, so thyroid stimulating hormone, the name tells you what it does, right? So thyroid stimulating hormone, it stimulates the thyroid gland to secrete thyroid hormone. Okay? This word, well, if you know this word, it helps, right? Adrenal cortex, any idea what that is? Renal. So if someone has renal failure, kidney, okay? So renal refers to the kidney. Adrenal, there's a gland called the adrenal gland that sits right on top of the two kidneys. So that's why it's called adrenal. So the adrenal gland has an outside, like the cerebral cortex, it has an outer adrenal cortex and an inner adrenal medulla. And we'll get to those. They're down here. So you have the adrenal cortex and adrenal medulla. So now you understand what that is. Adrenal cortex, the outer part of the adrenal gland. And so this hormone, ACTH, adrenocortico. So you see the adrenal has to do with adrenal, cortico has to do with cortex. Okay, so adrenocorticotropic hormone stimulates the adrenal cortex to secrete corticosteroids. All right, prolactin, LACT, does that help you in any way? Lactose. Prolactin is a hormone that stimulates the mammary glands and produces milk synthesis of milk, and also increase in testosterone secretion. Growth hormone tells you what it does right there. Promotes tissue growth. Okay, so you may expect for a person in their teens to maybe be producing a little bit more growth hormone than an adult or a young child. Okay, so that's kind of what I wanted to share with you all, how to prepare for this. So I would have, like I said, one set of cards, index cards that have the name of the gland on one side, all the hormones produced from that gland on the other side. Then I'd have another set of cards that have the name of the hormone, one hormone, like TSH. I'd have thyroid stimulating hormone on one side, and then on the other side, the effect of that hormone. So you kind of have two sets of index cards. One with the glands on one side, hormones on the other. The other set having the hormone on one side and the effects of that hormone on the other side. Okay, let me mention a couple more of these that may help you just to hold on to some of it, to make sense of it a little bit. So the posterior pituitary, so the pituitary gland has the anterior and posterior portion. The posterior part of the pituitary gland secretes the hormones OT, which is oxytocin. And by the way, you all need to know, if there's an abbreviation, you need to know the full hormone. Okay, so OT is oxytocin, and there is a table in your textbook, probably at the end of the chapter 17. So you can check the spellings. ADH is anti-diuretic hormone. Anti-diuretic hormone. Write that one down for me. I want you to tell me what you think that word means. Anti-diuretic. Well, what do you think diuretic means? What's a diuretic? So it's a chemical or substance that causes you to urinate, right? Okay, so if you take a diuretic pill, you're going to be running to the restroom quite a bit. Okay, release of fluid, elimination of fluid through urine. So if you have a hormone that is anti-diuretic, what do you think it's doing? Decreasing urine output, reducing the amount of urine released. Okay, so just the opposite of a diuretic. Well, there you go. ADH, anti-diuretic hormone. Now, does it have an effect on the brain, the lungs, the liver? No, that wouldn't make sense, right? So just the kidneys. Only the kidneys have receptors for ADH. Okay? So when ADH binds to the kidneys, it pretty much tells the kidneys to go ahead and return the excess fluid or the fluid back to the body. Because why? Now the next thing I'd like for you all to think about is, under what conditions would the posterior pituitary gland secrete ADH? Huh? What? Somewhat, yeah. That's true. Under those types of activities, but why? I mean, well, think about this. So if it's going to decrease urine output, under what conditions would you want your body to decrease? That's the word I was looking for. Yes. When you're dehydrated. So if you're dehydrated, what does that mean? Your body doesn't have enough water. So why would we want to lose any more water? Okay. So this is kind of an emergency situation where the body is already has a limited amount of water, so we don't want to lose any more. So that's when ADH is secreted. Okay? Causes water retention, decreases urine output. And this one you all may remember from Biology 201, calcitonin and PTH. You heard of those somewhere?
Yeah.
What does it have to do with? Good. Actually, it's just like what we said about insulin and glucagon. What's the relationship between insulin and glucagon? Don't say one increases, one decreases. Tell me which one increases and which one. Insulin lowers blood glucose. Glucagon increases blood glucose. So calcitonin decreases blood calcium. PTH increases blood calcium. So they regulate blood calcium levels. So you see what I mean? Every substance in the blood has to be regulated. You can't have too much or too little of anything if you want your body to function properly. Okay? So keep that in mind. So remember, but what does this have to do with bone? So this is how we control blood calcium levels. But what does regulating blood calcium levels have to do with bone? Or what does bone have to do with regulating blood calcium levels? That's probably the best way to say it. So notice the two hormones have what is their targets? Bone. Okay? And here bone in the kidneys. So when the thyroid gland releases or secretes calcitonin goes where? Into the bloodstream. Very good. And it binds to receptors on the bone. Okay? And so here's my question again. I asked, how does insulin lower blood glucose? Does it eat it? How does calcitonin lower blood calcium levels? So you have too much calcium in the blood. Here comes calcitonin. What does calcitonin do to the calcium? Does it eat it? Huh? It stores it in the bone. Okay? So it causes the excess calcium that's in the blood to be sent to the bone. And it actually stimulates a particular type of cell in the bone. I know you all don't remember any of the bone cells. So you have osteocytes and osteoclast. Good. Okay, y'all remember osteoblast. So what's the difference in an osteoclast and an osteoblast? So good. You have a good memory. So osteoblasts, remember the osteoblasts make bone, build bone, and osteoclasts break down bone, right? And why do we need both types of cells? Because one cell is constantly breaking down bone, the other one is constantly building up bone, and that process is called remodeling. So we remodel our bones throughout life. You don't want the same bone that you had 10 years ago, right? Or maybe you want it as thick. But over time, the cells get old and worn out, so they're just being broken down and built up. So you know which cells do what. So my question is, calcitonin stimulates one of those cells. Which one would that be? Osteoblast. Okay? So I should put up here as the target cell the osteoblast, because calcitonin activates the osteoblast to add that calcium, take the calcium from blood and add it to the bone. What about PTH? What is PTH, by the way? Parathyroid hormone. Parathyroid hormone. So parathyroid hormone does what to blood calcium and how? See if you all can tell me how it increases blood calcium. Somewhat. That's kind of what happened with glucose. But if you think to what happened with the what calcitonin did, calcitonin just told the osteoblasts to increase their activity, to add calcium to the bone. So PTH is telling the osteoclasts to speed up, act faster, to do what? How? Huh? To break down bone, because if you break down bone, that releases calcium. So remember, the bones are reservoirs for calcium, right? So all excess calcium can go be stored on the bone, but then when your blood needs more calcium, that calcium can be released by this process. Okay? So calcitonin adds calcium. Important to understand, it takes calcium from the blood and adds it to the bone. And PTH stimulates the cells, osteoclast of the bone, to break down calcium, to break down the bone to release calcium to the blood. Okay? So that's how that works. And also the kidneys. It says the kidneys here. The kidneys are in on just about anything that's in the blood. It can help to get rid of anything. It can't bring anything in. The most it can do is retain what is there, like with water. So the antidiuretic, the kidneys can the kidneys can bring the water back, but it can't increase too much. So what do you think, knowing that, what do you think PTH is telling the kidneys to do? So we want to increase blood calcium. What do you think the PTH is telling the kidneys? Huh? That's it. Not to release calcium, to let it stay in the body, because there's already a shortage. Okay? All right. How many of you all have had nothing to eat on this day? Me too. I'm doing bad the last few days. Been missing breakfast. So, those of us who have had nothing to eat, what do you think our pancreas is secreting right now? Yeah. So if you haven't eaten anything since last night, like I haven't eaten in 12 hours. So what do I need right now? I need some glucose. And since I'm not putting it in, it has to be released from storage, right? So the pancreas is releasing glucagon, right? So glucagon is telling my liver to go ahead and break down the glycogen. Okay. All right, that's all I have for today.